Now we'll discuss how to find out the gravitational field due to uniform hollow sphere. So consider that we are having a hollow sphere of mass m and radius r, and our aim is to find out what about the value of gravitational field at a point P, which is at a distance x from the center. So over here basically we can consider different cases. Let's say in the first case we are considering a situation where the distance x from the center, let's say x is greater than that of radius r. That means we are just considering a point outside the sphere. So if you are just considering a point outside, we can just assume that all the mass is concentrated at the center. So we can write the equation for this gravitational field while considering total mass is concentrated at the center, that is equal to gm by x square. So we can say that if x is greater than r, this g is inversely proportional to x square. Now we are considering a situation when this x is equal to nothing but r, means we are going to find out the value of gravitational field on the surface. So again from the equation we can write as gm divided by r square. Now I'll consider at a point inside this sphere. So we can consider the case when the value of x is less than r. So let's say if I'm just considering a point over here, so we can divide this sphere into two parts, something like this and like this. So gravitational field due to the mass on this side and gravitational field due to the mass on this side will get cancel each other, so that the value of net gravitational field at any point inside, including at the center, will be equal to 0. So we can say that if x is less than r, the value of g is equal to 0, or we can write the value of g inside will be equal to 0. So if you are drawing a graph which is showing the variation of this gravitational field with respect to distance from the center, so when the center to surface it will be equal to 0, and the surface it is having its maximum value, that is equal to gm divided by r square, and it is inversely proportional to x, and at infinity it is going to be equal to 0. So after this we can, it is inversely proportional to x square, and at infinity it will be equal to 0. This is showing the variation of gravitational field with respect to distance from the center of a hollow sphere.